then means non-flocculated suspension, we can transfer it or convert it in a flocculated suspension, right, by decreasing its particle size, whatever the suspended particles are present. If we reduce that their particle size, that time also we will make a non-flocculated into a flocculated one. Then also the, if we increase the density of our liquid vehicle, means our continuous phase from a suspension, or also we increase the, also we can increase the viscosity of our vehicle, right, by increasing the viscosity of our vehicle, and by increasing the density of a vehicle, we can also make the non-flocculated into a transfer, we can transfer the non-flocculated into the flocculated or unstable to the stable form of suspension, right, or also the, by decreasing the particle size of suspended material or suspended solid, right. So this is the way by which we can transfer or convert the non-flocculated into the flocculated one, right. So this is about the stability, small introduction about the stability of our suspension. Means stability is very necessary, stability of our suspension is a very necessary, right. So after that there is a various kind of test, varied kind of test, that is evolution test or evolution of stability of a suspension, right. Means by which, by applying the physical test of stability test of a suspension, we can determine the whether our suspension is a stable or unstable, right, whether it is stable or not, right. Means by performing the various kind of test or method, we can recognize the our suspension is stable or not, right. So let's see, there is a four kind of test or evolution test of suspension, right, evolution test of suspension. Means by this we can evaluate our suspension, that is sedimentation method, micromateritic method, rheological method, then electrokinetic method. Electrokinetic method, I think these methods are newer for you. Actually I thought your suspension is new for you, right, because it's your first time to you are studying, right. So sedimentation method, micromateritic method, then rheological method, then electrokinetic method. By this method we can determine, recognized, right, whether our suspension is stable or not, right. So let's see how can we recognized, right. So first of all, sedimentation method. Sedimentation method. So first of all, before starting that, I thought I will tell you that is sedimentation means the transformation of, or the means sedimentation means the solid particles, solid distributed particles are come to the bottom, means from the initial place of the solid or sediment, from the up to the bottom, right. Means agar जो distributed, you need to imagine it, right, you need to imagine it, just you may imagine it, right. Means the suspension that solid distributed particles are settled down, right, settled down to the bottom, right, settled down to the bottom, right, from the upper to lower, from the upper to lower, means that is the what kind of time or what kind of speed, right, which is take for the settle down of or come into the bottom portion, that is the sedimentation. मीन्स जो सॉलिड पार्टिकल्स है वो अब ऊपर से लेकर नीचे तक का जो दूरी है या फिर स्पीड है या फिर टाइम है, जो वो जो डिस्टेंस जो कवर करते हैं, सेटल होते हैं ऊपर से जो नीचे तक आने का जो डिस्टेंस है या फिर स्पीड है, उसे हम सेडिमेंटेशन बोलेंगे, ठीक है. देन द स्टडी ऑफ सेडिमेंटेशन वॉल्यूम मीन्स कितने अमाउंट में, कितने क्वांटिटी में जो सॉलिड पार्टिकल्स है वो ऊपर पोर्शन से नीचे के पोर्शन तक आता है, तो उसे हम सेडिमेंटेशन वॉल्यूम बोलेंगे, ठीक है. देन द स्टडी ऑफ सेडिमेंटेशन वॉल्यूम ऑफ सस्पेंशन इज वेरी इंपॉर्टेंट टू फाइंड आउट द वेदर द गिवन सस्पेंशन इज स्टेबल और नॉट, राइट, वेदर दिस our suspension is stable or not. Means it is very important or very commonly performing this method, that is sedimentation method, right? We can determine the with the help of sedimentation volume of our suspension, given suspension it is stable or not, right? The actually the sedimentation volume, the limit of sedimentation volume, it is from the 0 to 1, from the 0 to 1. Either our value of sedimentation value of our suspension is between the 0 to 1, that time we are called it stable, right? Stable form. But it is a close to 1, right? Close to 1 or near to 1, that time we will call it stable form of suspension, highly stable form of suspension, right? मीन जो सेडिमेंटेशन वॉल्यूम जो उसका एक रेंज है 0 से लेकर 1 तक, ठीक है? मतलब 1 के नज़दीक, मतलब 0.75, 0.80, 0.95, ये अगर रीडिंग जो आता है सेडिमेंटेशन वॉल्यूम का, अगर ये रेट अगर आता है, तब जाकर हम बोलेंगे कि और जो सस्पेंशन वो ज़्यादा हाईली स्टेबल है, ठीक है? तो उसका लिमिट है 0 से 1 तक है, तो 1 के नियर जितना रहेगा उतना हाईली स्टेबल रहेगा, ठीक है? तो लेट्स सी हाउ इट इज़ परफॉर्म्ड. Then first step, that is put a measured volume of suspension in a graduated cylinder in a unmovable position for a specific time. First of all, we have to need a measure a specific amount of our prepared suspension, whatever we are need to perform that our sedimentation method, right? Means whatever we will prepare the suspension, from that the some portion we have to take and measure it properly, right? And after measurement or measuring the volume of suspension, we need a one graduated cylinder. Graduated cylinder means that cylinder has a number scale on the surface of cylinder. There is a scale, measurable scale, or graduated means a numbering scale on it. I think you know that that is the cylinder, measuring cylinder contain a scale, one number scale, right? 10 ml scale, then 0 to 10, 0 to 15, right? So we need to take one graduated cylinder, right? In graduated cylinder we have to put that measurable suspension, right? And kept it into unmovable position, for a steady position, for a constant position we have to keep it for a specific period of time, right? For a specific period of time. Then after that, note down the ultimate height and initial weight of the total suspension and the वैल्यू पुट इन गिवन फार्मूला, राइट? मतलब क्या करना है, मेजरिंग सिलेंडर लेना है, ठीक है? मेजरिंग सिलेंडर लेना है और एक सम अमाउंट ऑफ, एक स्पेसिफिक अमाउंट ऑफ जो सस्पेंशन उसे मेजर करके सिलेंडर में ऐड करना. सपोज करो 10 ml लिए है, ठीक है? तो 10 ml सस्पेंशन डाल दिए, तो उसका जो मेजरिंग सिलेंडर में वहाँ पे वॉल्यूम दिखाएगा, रीडिंग दिखाएगा, दैट इज 10 ml सस्पेंशन. तो राइट, जो सपोज करो 10 ml तक डाले, तो 10 ml में जो लेवल रहेगा उसको हम पकड़ेंगे initial height from the 0 to 10, that is the initial height of our suspension, right? Then after keeping in movable position or a constant position for a specific period of time, for like 10 to 15 minutes, after that we will see that the suspension are settled down, right? Settle down up to its specific position, right? Means जो 10 ml तक लिए, तो वो क्या होगा, एक स्पेसिफिक पीरियड ऑफ टाइम के बाद वो क्या होगा, रिड्यूस होकर उसका सेडिमेंटेशन होने के बाद जो सेटल डाउन हो जाएगा, तो उसका जो लेंथ हाइट है वो क्या होगा, कम होगा. 10 से लेके या तो 8 आएगा या फिर 5 आएगा, ठीक है? तो इसी के बीच में एक आएगा जो वैल्यू है वो हमें दिखेगा, तो उसे हम कंसिडर कर लेंगे अल्टीमेट हाइट, राइट? 10 ml भले थे, स्पेसिफिक टाइम के बाद रीडिंग कहाँ तक आया, सेडिमेंटेशन होने के बाद, स्टेबल होने के बाद 8 तक, ठीक है? तो हमें यहाँ पे अल्टीमेट हाइट दिखाएगा, दैट इज 8. तो हमें वो दो जो वैल्यू है उससे नोट डाउन करना है. एंड आफ्टर नोट डाउन दैट, आफ्टर गेटिंग दैट नंबर और वैल्यू, वी शुड पुट इट इनटू दिस फार्मूला. दिस इज द फार्मूला फॉर द सेडिमेंटेशन वैल्यू, वॉल्यूम ऑफ आवर सस्पेंशन. देन वी नीड टू पुट इट इनटू दिस फार्मूला, राइट? F is equal to HU S0. HU means ultimate height and H0 means initial height, right? That is H0 is the initial where the height of suspension, HU is the ultimate height of a suspension. Ultimate means sediment after the some time, ठीक है, मतलब 10 ml तक भरे, उसके बाद 15-20 मिनट बाद जो हाइट आया, वो जो हाइट को क्या बोलेंगे हम लोग, अल्टीमेट हाइट बोलेंगे. मतलब सेडिमेंट होगा ना जो सस्पेंशन, वो सेटल डाउन होगा धीरे धीरे, तो उसका हाइट कम होगा. तो जो इनिशियल जो रहेगा आफ्टर फिलिंग, दैट इज द इनिशियल स्टार्टिंग वेट, दैट इज after that, after the before time, after the some time, that is the ultimate height. And f is a sedimentation volume of a suspension, right? तो हमें वो फॉर्मूला में पुट करना है एंड देन देखना है कि क्या वैल्यू आया. ठीक है, देन द एफ वैल्यू कैन बी प्लॉटेड अगेंस्ट टाइम. अ स्टेबल सस्पेंशन विल शो horizontal or less steep curve, right? After that, after getting the value of f value, that is the sedimentation value, we need to, means this sedimentation process we will carried out up to the 5 to 4 time, means 4 to 5 time we need to carried out it, right, with the same suspension, right? After that, we at that situation we will get a one specific f value for a first study. For first study is a one value, for second study is a second value, right? Up to the we have to done it for a 5 time or 4 time, right? After that, that value f value should be plot on the graph, that is times value f value against the time. मीन्स क्या होगा, एक ग्राफ हमें प्लॉट करना रहेगा, तो x जो y एक्सिस है उसमें जो सेडिमेंटेशन वैल्यू मिलेगा उसे हमें पुट करना है, और जो अगेंस्ट जो टाइम, मतलब एक स्पेसिफिक फर्स्ट वाला जो वैल्यू निकालेंगे वो 10 मिनट के लिए, सेकंड या फिर 5 मिनट के लिए, फिर सेकंड निकालेंगे 6 मिनट के लिए, या फिर 7 मिनट के लिए, ऐसे 2-2 मिनट का गैप देके हम लोग ऐसा सेडिमेंटेशन वैल्यू जो है उसे निकालेंगे. ठीक है, तो वाई एक्सिस पे क्या करना है, हमें एफ वैल्यू पुट करना है, और एक्स एक्सिस पे क्या करना है, हमें टाइम 5, 6, 7, 8 ऐसे करके प्लॉट करना है. ठीक है, तो हमें एक ग्राफ मिलेगा. अगर वो जो ग्राफ है वो अगर हॉरिजॉन्टल आता है, हॉरिजॉन्टल लाइन अगर आता है, तब जाके बोलेंगे हमारा जो सस्पेंशन है वो स्टेबल है. या फिर लेस स्टीफ, थोड़ा सा कर्व अगर आता है, तभी हम कंसिडर करेंगे द ओवर गिवन सस्पेंशन इज अ स्टेबल, राइट? Then the evolution of redispersibility can also determine by shaking suspension and again find out f value of a suspension, right? Means first of all जब हम लोग f value निकालेंगे जो suspension का, ठीक है, उसको और से रिडिस्पर्स करना है, देन सेकंड वैल्यू और से निकालना है, देन अगेन we should follow that procedure again and again, right? So by which we can find out the f value, and with the help of f value we can know the, or we will know the our suspension is a stable or not. If we will got a straight horizontal curve, that time we will consider that is our suspension is a stable. Also we get a less stiff curve of graph, that time also we consider it, that is our suspension is a stable also, right? So this is a very simple and very important method of evolution of suspension, that is a sedimentation. We will also, it is perform in our practical also, whenever we are when we will going for performing our practical in a practical, right, in our lab. So you just remember this formula and just remember the, or understand that procedure also, right? Very small procedure or very simple procedure it is, right? Then afterward our micromeretic, right? Afterward our micromeretic is also one of the evolution test for a suspension for determining the whether it is stable or not, right? So let's see what is that. Actually also the stability of a suspension depend on the particle size of a dispersed phase, right? As I said before, the starting means from the starting our chapter, that is suspension, I also has been had been telling you that is the particle size is very important. Our for the suspension, that is particle size plays a very important role. If our particle size is in required range, that time we will get a stable, otherwise unstable, right? That's why also we can transfer the non-flocculated into the flocculated one by the decrease in the particle size, right? So it is plays a very important role, right?